Hi everyone, welcome to this tutorial on building a library management system with Harper. Today I'm going to show you how Harper makes building robust APIs straightforward and efficient. If you've ever wanted to create a system to manage books and library members without dealing with the complexity of connecting separate databases and API layers, you're in the right place. In this video, we'll cover setting up our projects with Harper, defining our data model using GraphQL, implementing resource classes for books and members, and testing out our API endpoints. What makes Harper special is its unified approach. We'll define our schema once, and Harper automatically creates both REST and GraphQL endpoints for us. Let's get started by understanding what we're building. Our library management system has two main components. First, we have book management for creating, retrieving, updating, and deleting books in our library catalog. Second, we have member management for handling library patrons with similar CRUD operations. Each book will have its properties like title, author, and availability status, while members will have personal information and a record of borrowed books. This is a foundational system that you can extend with features like reservations, late fees, or categorization systems later on. Let's begin by setting up our development environment. If you haven't installed Harper yet, check out our previous tutorial for installation methods. For this video, I'll assume you already have Harper installed. Let's start by creating a new project directory and initializing it with Harper's application templates. Now, we have our project structure ready. Let's open this in our code editor. As you can see, we have the basic files we need to get started. Now, let's define our GraphQL schema. We'll create a schema.graphql. It's already there, but all you need to do is add your declarations in there. We'll add our data model. Let me explain what we're doing here. We're defining two entity types, book and member. The table directive tells Harper to create database tables for these types. The export directive automatically exposes them through REST and GraphQL endpoints. We're setting up fields like title, author, ISBN, published year, genre, availability for books, current borrower ID, name, email, membership date, status, and borrowed books. What's powerful here is how declarative it is. With these few lines, we're defining both our data structure and API interfaces in a single file. Harper will handle all the heavy lifting for us. Now, let's create our resources.js file to implement the business logic for our API. We'll start with the books class. In this books class, the constructor extends Harper's resource class and connects to the book table we defined earlier. Now let's add the post method for creating new books. This method does several things. It parses the incoming JSON data if needed. It sets the default value of true for the availability field. It prevents clients from overriding the generated ID, and it inserts the record and returns the results or handles any errors as needed. Let's add the get method. This method handles both getting a specific book by ID and getting all books. Harper's getID method automatically extracts the ID from the request URL. So, if we have the ID, we get the particular book with the particular ID that we want, and if there's no ID, it returns the entire book list. Now, let's add the put method for updating books. This method is similar to post, but it requires an ID and uses the table's put method. Finally, let's add the delete method. This method extracts the book ID from the URL, validates it, and then removes the book from the database. Now let's implement the members class with similar functionality, but for member-specific fields. Our members post method is similar to books, but it sets member-specific default values like today's date for membership dates, active for status, and an empty array for borrowed books. Let's add the get, put, and delete methods, which follow the same patterns as the books class. With just these two classes, we've created a complete API for managing both books and members in our library system. Now let's run our application and test it. Open your terminal and type harperdb dev. Harper is automatically creating the database tables based on the GraphQL schema, setting up the REST and GraphQL endpoints, and connecting our resource classes to these endpoints. Now let's test our API using a tool like Postman. First, let's add a book. As you can see, now we've added this book and it returned my book ID. So I'm going to copy this book ID. And now let's try to retrieve our book using our ID. So I'm going to switch to the get method and attempt to retrieve this. And as you can see, it shows. Now, let's add a member. As we can see, our member is added. And now I want to borrow a book as a new member. So I will come here and copy this book ID like we know it. And then I will add it to this payload. And then I would also add the member ID because now I'm about to send a put request. Just so it looks clean. And I change this to a put request. And then now I want to add this to my list of borrowed books. And it says that the member is updated successfully. So now what's going to happen is that when I say I want to retrieve this member, let's say I want to retrieve this member like this, sending a get request, I would see myself as a member with this being in my list of borrowed books, as we can rightfully see this. Our library management system now has solid core functionality, but there are many ways you could extend it. You could implement book checkout and return operations. You could add search functionality to filter books by title or author. You could incorporate authentication to protect your API. You could create reports on library usage. These patterns we've established make it easy to add these features as needed. In this tutorial, we've built a complete library management system using Harper. We've seen how Harper's unified approach simplifies API development by defining our schema in GraphQL, automatically creating REST and GraphQL endpoints, providing a clean way to implement business logic through resource classes. The system we've built is scalable because it can handle growing collections of books and members, extensible because it can build on patterns that can be expanded, maintainable because it's organized in a clear modular structure, performant because it benefits from Harper's unified runtime. Whether you're building a small personal library tracker or a system for a large institution, Harper provides the tools you need to create robust, efficient APIs without unnecessary complexity. I hope you found this tutorial helpful. Please like and subscribe for more content on Harper and modern API development. Feel free to share what you build using this pattern in the comments below. Thank you so much for watching. Bye!